Hello, Yuma. We are going to be working out of section 10.2 today, finding areas of trapezoids, rhombuses, and kites. I think you're going to like this one. All right, let's get right into it. The area of a trapezoid. Well, you remember how the area of a rectangle or a parallelogram was the base times the height? Well, we got two different size bases. And basically how it works, folks, is we can take the average of the two bases, add those together and divide by 2, and we get something that will kind of look like a rectangle if we do it that way. Anyway, basically let's boil it down right to its formula. The area of a trapezoid is 1/2 of the product of its height and the two bases added together. Or area equals 1/2 height times the two bases added together. Fair enough? Now remember, the bases of a trapezoid are the parallel sides, and the height of a trapezoid is the perpendicular distance between those two bases. Clear enough? Let's use a couple of them. All right, plain and simple. Pause if you want. Here comes an answer. Area is 1/2 base 1 plus base 1/2 the height times the sum of the bases. Height is 7. Bases are 12 and 15. Add it all up, solve. There's our area. Cool. Nice, quick, easy. Try another one. Dang, we're going to make it harder on you now. Okay, so what's the area of this trapezoid? Okay, pause, think about it. Let's go from here. A couple things we know, all right, let's get her going again. All right, first thing is angle P has to be a right angle. Okay, we got to have a pair of parallel sides to make it a trapezoid. It tells us it's a trapezoid. So these two sides must be parallel. P must be a right angle, right? Okay, so next thing I know then is if I draw altitude from S on over here, okay, so that it's parallel or perpendicular to QR, well, I formed a rectangle over here, right, where the sides are 5 and 5, and I still don't know this height though, right? So we still need to work on that a little bit. Okay, let me reset it and show you the answers, okay? But that's basically where I'm going to be going with this. If that helps get it going, then we can get it going. Okay, move that out of the way. So anyway, they gave us bases of 5 and 7, but they didn't give us a height. P must be a right angle, otherwise we got no parallel sides, and it's not a trapezoid. Should read trapezoid right here, guys. Okay, trapezoid. Anyway, so we can then draw a line from S that's perpendicular to this segment. You know what? I've already cheated, and I'll put that in there. Okay, I have to find the figure though. Let's see if I can do this. Yeah, want that out of there. All right, so here's my figure, all nice and pretty looking. Okay, so we can draw this segment from line S that's perpendicular. We can draw a line from S that's perpendicular to QR, and we call it T. Now, we know we've got this rectangle up here, but more important, we also know we have a 30, 60, 90 triangle out here in STR. Okay, since QS, or since QT must be equal to PS because of the rectangle, right? That's got to be 5. Therefore, TR must be 2. Now we remember our 30, 60, 90 rules. If the short side of a 30, 60, 90 triangle is 2, then we know the height, the long leg must be 2 times the square root of 3, right? Remember that rule? 2 times the square root of 3 is 3.46, and that, my friends, gives us the two bases and the height for this trapezoid. Okay, so now we just use our formula, 1/2 the height times B1 plus B2, put our 3.46 in for the height, 5 and 7 in for the bases, and we find that figure must be 21.78 square centimeters. So remember, we're going to be using some of our old skills along with these new ones. Next, let's talk about rhombuses and kites, and you get a twofer here. because we actually have two figures that have the same formula. Area is 1/2 the product of the lengths of the diagonals. So take the diagonals, multiply them, divide by 2, and you got the area of both a rhombus and a kite. So let's check out a couple. Area of this figure, use your formula, plug in your diagonals. Area is 21 square meters in this guy. Verbally here, we got a area of a kite. Diagonals are 12 and 9. Plug in 12 and 9 for D1, D2. We have 54. Let's do one that's a little harder. Okay, HOV lanes in some big cities made with these big old white diamonds. Okay, here's some dimensions. Pause, think about it. Here comes your solution. Now, since the diagonals of a rhombus bisect each other, well, if this guy's 2.5, this guy must be 2.5. Therefore, the horizontal diagonal must be 5 feet long. Okay, now, how about this height, other diagonal? Now, once again, we're going to go back and use our Pythagorean theorem because we got a triangle. It's got to be a right triangle because for a rhombus, diagonals must be perpendicular, right? So we'll use Pythagoras, which tells us that 2.5 squared plus x squared, I call this x. 2.5 squared plus x squared must be the hypotenuse squared, 6.5. Do our math. We find that x must be 6. Therefore, if this is 6, this is 6, and the long diagonal, the up and down diagonal, must be 12 feet long. Now we plug it into our formula. 1/2 times 12 times 5. The area of this guy is 30 square feet. That's all I got. Talk to y'all later.